So, hi everyone. I'm Tiziano Piccardi, PhD student at EPFL, and I'm going to present you a project in collaboration with Miriam Redi of Wikimedia Foundation, Giovanni Colavizza of University of Amsterdam, and Bob West, my advisor at EPFL. Content integrity is one of the most crucial aspects for the existence of Wikipedia. One critical component to ensure that the content of the article is reliable is to cite the source of the information. And according to the documentation of Wikipedia, citation allowed the reader to determine if a reference material support the author's argument. But when content should be referenced in one article, Wikipedia has a detailed policy for the editors about the verifiability of the content. And in few words, it states that the articles require inline citation for every statement that could be challenged by the readers. This policy led to the creation of a reference section at the bottom of the article, similar to the format used in academic publications. In this example, we can see that the highlighted sentence has a footnote number that refers to an external website with the source of the information. So despite of this crucial role of the citation for the verifiability of the content, very little is known about how readers use them, especially in this time of when misinformation is a critical aspect of our society, and we have a credibility crisis of the web. Understanding how the reader look for content online is extremely important to determine the policy and to inform the design of the platforms, the interface. Of course, this problem involves all the content online. In this project, we focus on Wikipedia because as the fifth most visited website in the world, we think it can give good insights about the behavior of the internet population. So to better understand the reader behavior, we investigate three research questions. First, we need to understand to what extent the user engage with the citations. Then we wanted to understand what features of the page predict the interaction with the citation. And finally, we want to understand what feature of the citation predict the interaction. I say the interaction, and to answer this question, we have to define what interaction with a citation means. And for this reason, we identify 6 types of events in the page. So first, we need the page load event to know how many times the article was loaded. Then the footnote click, that is the event that caused the browser to jump into reference section by when the user click on the small footnote number. And the complementary event, up click, that caused the browser to jump from the reference section to the context of the citation in the body of the article. Then we have the event footnote over, that records when the pointer of the mouse is moved on a footnote number, and a small pop-up with a preview is shown. Then we have the actual click on the reference that caused, of course, the browser to go on the destination, and external click, that is a generic click in the page to an external destination, but not into references. We collected these events for the English Wikipedia in 2 sessions of 1 month, October 2018 and April 2019. This was the first time that this data was collected, so we had to develop a client-side instrumentation to capture all these events. I want to point out that to preserve the privacy of the users, We included only anonymous users, that is the vast majority of the readers in Wikipedia. We anonymized the data by dropping sensitive information, and all the sensitive data is deleted after 90 days. We have similar values for the two data collections, so we can focus on the most recent one, April 2019. In total, without considering the page loads, we collected more than 96 million events. And from a preliminary analysis, we can observe that 1 in 3 is an over event, with, of course, a large majority generated from desktop mobile. We see that references click are more common on desktop devices, and the up click event is a very rare event. In our analysis, we focus on references, so we focus in particular on reference click, footnote over, up click, and footnote click. So now we have the data, and we can move to our first research question. To what extent users engage with the citations? First, we have to define, of course, the metric we want to use to measure the level of engagement. One classic approach is to look at the click-through rate. And in our case, we define a custom version by considering positive a page load where there is at least one click in the reference section. So in simple words, we want to measure what is the probability of observing at least one click given a random page load. And this probability is relatively small. It's 1 in 340. Or in other terms, 0.29% of the page loads have at least one click on the references. We saw before that the over event is more frequent. And given a random page load, we can observe one over event in one case every 70 page views. Another interesting analysis to understand the user behavior and to study the transition probabilities. Given the data we collected is event stream, we can also study the sequence of events and model the transition probability with a simple Markov chain of order 1. Like in this example, we have page load followed by page load, footnote over, a click, and what we observe is that, for example, page load is followed by another page load for 46.9% of the time. Footnote click is followed by a click on the reference 33.8% of the time, indicating that the click on the footnote number is a good predictor of clicking on the reference link. Differently, over is rarely followed by a click on the reference. And the readers tend to explore the references by going from preview to preview with 28% of the time. Another aspect that characterizes the user behavior is where the users go when they click on a reference. In terms of the most clicked domain, we notice that Google leads the ranking, followed by DOI and some news outlet. By looking at the full domain, including subdomain, we observe that the majority of the traffic directed to Google is toward the domain books. So, takeaway of research question 1 is 1 in 340 page loads, we can see a click, at least one click on the references. 1 in 70, we can see at least one over. And the most frequent destination of the outgoing traffic from Wikipedia are Google subdomains, scientific articles, and news websites. So now we can move to research question number 2. We want to understand what are the features of the page that predict the interaction. To answer this question, we identified 22 features of the page, such as page length, number of references, popularity of the page, and we selected from ORES, that is the scoring platform of Wikipedia, topics, that is a vector of 42 dimensions, and the quality classes. The topic distribution in particular is a vector of 42 indicators that can be interpreted as the probability that one article belongs to each of the topics. Since the article can belong to multiple topics, they are independent between 0 and 1. To study the impact of these features of the interaction with the references, we train a logistic regression to predict if a page will follow by an interaction with a reference. In particular, by observing the importance of the feature, we can notice that the quality is a strong negative predictor, meaning that low quality articles are more correlated with interactions with the references. On the other side, we noticed that language and literature, that means biographies, and internet culture are positive predictors. Since quality is a strong predictor, we should investigate more this feature. We are interested to understand what is the effect of quality on the click-through rate. A naive approach is to compare the click-through rate of low quality and high quality articles, but this would not take into account the possible effect of confounding variables. For example, if all the articles with low quality were about a specific topic, we cannot separate the effect of quality from topic. More concretely, we know that language and literature articles tend to receive more clicks on the references. In this context, if most of them were low quality articles, it would be harder to disentangle the two. So for this reason, we proceeded with a matched observational study. The goal is to compare the click-through rate of pairs of articles, one high quality and one low quality that are identical in all the other features. To define this matching, we use propensity score that gives us a way to obtain the probability of being treated, in our case being high quality, as a function of the other observed covariates. The method uses a logistic regression to learn the probability of belonging to one of the two classes given the original set of features. The matching is then obtained by creating pairs, one high quality and one low quality, that minimize the distance on this probability function. We obtain in this way a matched dataset with 854,000 samples with all the feature balance, as you can see in the example on the right, where there is the histogram of the page length before the matching and the page length after the matching. So with this matched dataset, we were able to study the click-through rate of the two quality classes. In this plot, we visualize the difference in the click-through rate in function of the popularity of the page. On the y-axis, we have a click-through rate, and x-axis, we have the popularity of the page in terms of number of pages. We can notice here two effects. First, there is a negative correlation between the popularity of the page and the click-through rate. Second, there is a consistent and is statistically significant difference between the click-through rate between high quality and low quality. The first effect, the correlation, negative correlation, could be explained with a different type of audience that visit the page. Popular pages have a very broad audience, while unpopular pages can have a very focused set of readers. The interpretation for the second effect, higher click-through rate for a low-quality article, is that a page with complete information causes the reader to click on the references in search of more content. In practice, the page doesn't satisfy the information need of the readers. We also ran a similar analysis by investigating only page length. You can check the details in the paper. We observe even stronger effect by studying page length and by controlling for the type of article and also by readers community. So takeaway of the second research question is that people tend to interact more on the references of pages with limited content, short articles and poor quality. And popular articles have a lower click-through rate. So we can move to the last research question. What are the features of the page that predict the interaction? For each reference, we extracted the text of the reference itself and the sentence where the footnote appeared. We represented the two sentences as a binary bag of words. And we added two constraints in this feature extraction. We need the negative sample to be the closest reference in the page. In this way, we are sure that the user at the time that interacted with the positive could see also the negative, and also we reduce the effect of user that read only the header of the page and ignore the rest. And we also, to make sure to avoid over-representation of users, we took only one pair for every reader. To study what words are correlated with high interaction, similarly to the previous case, we then trained a logistic regression. And we studied the features, in this case words, that are positive predictors. The results show that people tend to interact more with recent content, for example, the keyword 2019, sentences that describe open access resources like free PDF, and sentences about human aspects like born, die, relationship, family, wife. Similarly, we run an analysis with Empath, that is a tool to generate lexical categories from text. And we noticed that categories that more frequently are clicked reference to human factors such as wedding, family, children, death, and so on. So to conclude, we learned that the click on the references is relatively rare. It's 1 in 340 pages, and over is a bit more frequent, 1 in 70. Readers tend to engage more with references on short pages. In relative terms, click-through rate, popular pages shows less interaction with the references. And we learned that readers engage more with the references about a recent event, describing human aspect and offering open access. So to conclude, for the first time, we were able to quantify the interaction of the reader with the citations. But what are the implications? This is, of course, the first attempt to study this behavior. And these results can enable the researcher to develop novel theories about information needs. These results can also support to create priority in the effort of improving information reliability. And we also confirm the importance of open access and open science initiatives. In practice for Wikipedia, this means that with these results, we could design a model to predict the lack of information by using signal of the interaction with the page. This model can also help to create priorities of content that need expansion to create a recommender system for the editors. And we can create a priority list of sentences that need a reference based on the reader interest. Thank you for your attention, and if you have questions, happy to answer after the.
Yeah, really great presentation. We have a few minutes before the next presentation. If any of the participants, if you have a question, you should just click the raise your hand, or you can type in the chat. We can take maybe one or two questions if anyone has any. I had one question. Can we learn anything about the users that click on the reference, or since this is an anonymized data set, are you not able to speak to, like, are there regional differences, or does tenure on the platform matter for users who say might have been on Wikipedia longer? Do we know anything about the users and what they click?
Yes. Okay, now this data is not available anymore because we had Wikimedia policy is for 90 days you can retain the data, and then you have to delete it. But yes, the original dataset had geolocation information, and I looked into it when the data was available, and yes, there are regional differences. We didn't include this in the paper, but we noticed there is if I remember well, there was also a difference in click-through rate between countries, and probably indication of different intent of using Wikipedia. Some countries probably use Wikipedia more for to study content. I think India had a higher click-through rate on scientific publications.
Yeah, makes sense. Let's see if we have any more questions.